Uh, Good morning, everyone. My name is Gary Wu. I'm here along with my colleague An Ho here from Huawei. We will be leading this discussion on the NEMO project on behalf of the NEMO PTLs who are unfortunately not able to be here today. So we will do our best to answer any questions that you may have about this project as well. But if there's anything in depth and technical that we're not able to, then we definitely recommend that we follow it up with the NEMO dev mailing list, which I encourage everyone to subscribe to anyway if you're interested in the NEMO project and want to stay up to date on the latest developments there. Okay, actually, to get a show of hands, how many people are familiar with the NEMO project right now? Okay, not too many. So then in that case, I will probably do a little bit more of the introduction to what the NEMO project is about. So NEMO stands for Network Model, and it's a language-styled effort to create a network intent engine. I think one way for you to think about it is it's almost like a SQL for defining network service functions or requesting network service functions. So why do we want something like this? The RDBMS world is actually a very good example. How do we come up with SQL? There's a huge proliferation of database engines that all had different ways of accessing it, right? So the industry quickly realized that it would be great for actually the RDBMS industry as a whole if we could standardize on how applications could request services from database engines, right? So we feel that something similar can be said about the SDN world now. We're just starting in the early years of the SDN world and industry, and already we're seeing many different types of SDN core controllers that are all competing in the industry for attention from application developers, right? So wouldn't it be great if we can have a standardized language that all the applications could code to, and then remove yourself a little bit from the sort of the specific implementation requirements and constraints on how to actually code against a specific controller. So at least that is the goal and grand ambition. As those of you who might have familiarity with the database world, we know that there is a SQL standard, but every vendor still ends up with slightly different implementations or quirks or syntax differences. We're hoping that that doesn't happen again, but I guess we will see years from now whether that happens or not. So to me, this graphic here is probably not that easy to understand. So I'm going to switch out of this and show a quick example of what I mean by like a language-styled intent framework. And what I'm going to show is actually this. I hope everyone could read that. Let me see if I can enlarge it a bit. What I'm showing you right now is actually a snippet from the NEMO project where we go through the actual language definitions and the high-level architecture, et cetera. But what I want to show you right now is when I say it's like a SQL for network services, there's literally a language definition that we have proposed for as an IETF draft. And we have the concept of connections and nodes and flows. And there's a standard language and syntax that you can use to actually place demands for certain types of services on the network fabric that your application requires. So you can always think of your network application as something that demands network services, right? You just care to have the services available to your application. You ideally not want to worry about how exactly to get that accomplished. So we're hoping that a standard language like this will allow your applications to easily be able to adapt to different types of controller implementations. So you can see that the language is a little bit similar to, let's say, SQL. You can create connections, you can create flows, and create operations. Are there any questions so far? Okay. And then in terms of the architecture, we have a northbound REST API that has been implemented as of Beryllium. The REST API takes in two types of input, what we call language style, which is literally you enter the commands like I showed you before, the create node or create connection like this on top here. And then we have a separate set of endpoints for what we call structure style, which is allowing you to put in similar requests but in more of a structured JSON format. The two will accomplish the same goals in the end. So it's really up to you as to which method may be the best for your purposes or the easiest for your users or developers to understand. So let's say you send in the create command into the REST API. So the NEMO engine will implement, basically actually parse it, compile it, and then does things like the syntax and semantic checking, and then do a mapping to the node entities to the virtual network, and apply that onto the physical network topology to figure out which physical devices should actually get, let's say, updated flow tables. And then we have a layer of renderers underneath, which will interpret that. In the Beryllium release, we have renderers in OpenFlow and in CLI for more legacy devices. But we certainly have developed it in a modular framework so that if we want to plug in additional renderers for other protocols, maybe netconf or something, that will be easily doable. And then, so the renderer takes the translated commands in terms of which devices need to have a flow table updated. For example, then those netflow commands get issued out to the actual physical devices and the underlying topology. Are there any questions? Okay. So roughly speaking, that is what this slide was trying to indicate. I was hoping that maybe going through the other graphic will maybe a little bit easier to understand. So I'm going to move on from here. But at a high level, again, actually one feature that I did not mention so far is we built it from the ground up to support multi-tenancy. So this is very important in particular for, let's say, a service provider network where you might have different customers who have individual network requirements from their applications that may actually map underneath to the same set of physical devices. So we want ability for the service provider to partition the network access based on individual, what we call tenants concept, and make sure that each tenant gets the required network services that they request, but there's no, let's say, leakage of network information from one to the other. Okay, so this is a similar rendering for the whole process flow of what I just described. The application provides as input let's say the language style commands in NEMO, which are application centric, and then we take that and we do an internal mapping in terms of what that means onto the virtual network topology, and then that is next then translated into the actual flow table updates for the underlying network topology. Here is a graphic for the NEMO engine as it has been implemented today in Beryllium. So all the white boxes are the ones that have already been done. The orange boxes that you see are the ones that are currently still incomplete. And this is an area where We're hoping that maybe through this session, we could maybe get some inputs from those of you who are interested in the development of the NEMO project as to what are the things that we should maybe think about or consider or perhaps potentially prioritize. And then, so I will go through what we currently think are probably the top priorities in terms of the NEMO project for boron. But obviously, definitely open to inputs from anyone who may be interested. Okay, so the first unsolved issue that we're facing in doing the intent engine right now is the resource mapping algorithm. So, for example, as you've seen in the language style commands that before, we can create nodes and we can create links, which are connections between nodes in terms of the traffic that you want to allow. So when you create a node, you can specify a set of physical devices. When you specify a link, we're not placing any demands on how the link is actually fulfilled. So the common existing implementations for doing this kind of translation, for example, for calculating the path, you would do it based on a shortest path, right? Now, as you can imagine, when there's a lot of policies that are being requested, when there are a lot of different network service requests, they might overlap, they might compete with each other. And then the mapping of individual nodes to the actual physical device for each particular flow may also compete with, let's say, the shortest path computation. So in this case, ideally, there should be some sort of joint optimization across the various areas. So this is currently one big topic that we feel like is probably deserving of a lot of research, and we don't have the solution yet, but certainly are interested to hear if anyone has any thoughts on this particular area or topic.
If I have right abstracted model, I don't really care about how I do it southbound. I mean, are you building something in parallel, or how should I see it?
I think there are sort of maybe two perspectives on it. One is, depends on whether you want to potentially decouple yourself from the particular requirements of a single SDN controller, right? So as I mentioned earlier, one of the reasons why we want to have, let's say, the standardized language is so that you can apply this potentially onto Open Daylight or onto some other SDN controller if they all support the same northbound language. So this will allow your application to be not locked down to a particular controller implementation.
And language and semantics is one thing. The way you are building it, it looks somewhat not in a way ODL worked. It was envisioned to work through modeled abstraction and complete decoupling southbound protocols.
So the goal of NEMO isn't, so the goal of NEMO is to provide a more natural language for the admins to use intents. We actually do integrate with MDSAL. If you go back to the architecture diagram, if you go back to the architecture diagram, our data store is still using MDSAL. We're still integrating with the rest of projects for Open Daylight. And we actually do also integrate with with a NIC project. We have a renderer in the NIC project. So we're definitely trying to get other projects, collaborate with other projects. But just to clarify, our intent is to provide a more natural language style, domain-specific language for you to specify your particular intents. If you can go to the previous slide, yes, this one. So the admin would the application developer or the admin or the orchestrator would be more focused on the application-centric intents and define it on a very high level. Everything else gets abstracted to the network-centric or the deployment-centric environments. The other thing is down below, we're also using OpenFlow. So that's one way. We provide CLI renderer only because there are certain legacy devices that may not support OpenFlow at the moment. Yeah.
I completely understand what you're trying to do northbound, and it's valuable for everybody. So you're building renders which are coupled directly with your app just for sake of proof of concept, or why are you doing this?
We have a demo. We actually have a couple of demos. We had one in the IETF hackathon. And we have a demo deployed on our wiki that you can check. At the moment right now, it's more, NEMO is more doing for demo purposes. We don't have a real deployment right now. Yeah.
So you have integration with NIC, right? But GPB, NIC, and NEMO, how are they different? I mean, you are trying to solve the same problem. You give high-level intents and then you push rules to the network, and then you integrate within each other. But all three are trying to do the same thing, right? Okay. And in case of conflicts, right? So how do you deal with it today?
I believe that's in one of our slides.
That's one of the open to do items.
So Gary, maybe if you can talk a little bit about that slide.
Oh, were there any other questions on, like right now, before I move? Oh.
Do you have integration to Boulder? Do you have integration to Boulder project? Like, it's okay. It's also similar, right? They are trying to do NBI.
Yes, so there's quite a lot of projects trying to do that.
Yeah.
Trying to define a northbound API. So NEMO is just one of them. Go ahead.
Okay. Okay, another area that is in need of sort of thought and research is in the area of service chain enhancement. So the application, or let's say the administrator, places demands on the network service function really without specific indications of things like load balancing, scalability, and failover. So this is something that currently is basically left up to the NEMO engine to provision and provide. However, at least right now, it's not very clear exactly how this would happen if it was not explicitly specified by the users or the administrators. So nonetheless, this is basically a set of mandatory features that, in particular, folks like service providers would demand. So just to throw this out there to see if anyone has any thoughts or any recommendations if you have worked in this area, for example. Are there any questions on this topic area or comments? Okay. And then one last one is exactly back to your question, which is how do we deal with conflicts, detection and resolution. So the problem here, just to restate, you could have, let's say, different users or different administrators, different applications, placing concurrent demands for network services on the same fabric. Invariably, there will be conflicts between those demands. So this question has two parts. One is how do you detect such conflicts, and then two, how do you resolve it? What do you do with it, right? So again, a very broad sort of problem area. We do have, at least for the detection case, we do have an idea that maybe we could use some sort of, let's say, lambda calculus to actually formally solve or prove out conflicts. But that's only one possible approaches. And again, not clear that this is the best way to do it, but this is one potential way of detecting a conflict. And then what do you do after that once there's a conflict? If there's one policy that demands a particular firewall port to be open, but another that demands it to be closed, what do you do? Who gets the dibs, for example? Any questions or comments? Okay, that's pretty much the conclusion of this session. So if you have any more detailed questions or comments, please definitely feel free to come up to either myself or An. And also, like I said, we would definitely encourage and invite everyone to subscribe to the NEMO Dev mailing list so you can keep up to date on the latest developments. And if you have any particular interest in joining this project and see how it moves forward, we're definitely open to all the contributors' inputs that we can solicit. Okay, thank you very much. Competing in the industry for attention from application developers, right? So wouldn't it be great if we can have a standardized language that all the applications could code to, and then remove yourself a little bit from the sort of the specific implementation requirements and constraints on how to actually code against a specific controller. So at least that is the goal and grand ambition. As those of you who might have familiarity with the database world, we know that there is a SQL standard, but every vendor still ends up with database engines that all have different ways of accessing it, right? So the industry quickly realized that it would be great for actually the RDBMS industry as a whole if we could standardize on how applications could request services from database engines, right? So we feel that something similar can be said about the SDN world now. We're just starting in the early years of the SDN world and industry, and already we're seeing many different types of SDN core controllers that are all do anyway. If you're interested in the NEMO project and want to stay up to date on the latest developments there. Okay, actually, to get a show of hands, how many people are familiar with the NEMO project right now? Okay, not too many. So then in that case, I will probably do a little bit more of the introduction to what the NEMO project is about. Good morning, everyone. My name is Gary Wu. I'm here along with my colleague An Ho here from Huawei. We will be leading this discussion on the NEMO project on behalf of the NEMO PTLs who are unfortunately not able to be here today. So we will do our best to answer any questions that you may have about this project as well. But if there's anything in depth and technical that we're not able to, then we definitely recommend that we follow it up with the NEMO Dev mailing list, which I encourage everyone to subscribe. So NEMO stands for Network Model, and it's a language-styled effort to create a network intent engine. I think one way for you to think about it is it's almost like a SQL for defining network service functions or requesting network service functions. So why do we want something like this? The RDBMS world is actually a very good example. How do we come up with SQL? There's a huge proliferation of